All right, so in this particular one, we have two balls that are hung from cords. It's just the first ball has a mass of 1 kilogram, and then it's pulled and it's released, and it reaches a speed of 2 meters per second at the bottom of the swing. And then they are going to collide and stick together, and then it's just the speed of the system after is 1.2 meters per second. And it wants us to find the mass of the second ball. All right, so here's a diagram. I'm just going to go ahead and label things so that it's easy to use subscripts. I'm just going to go ahead and call the first ball ball A, the second ball that is initially at rest ball B, and then the speed of the first ball before it collides with ball B, that'll be 2 meters per second. And then the speed of the system is 1.2 as stated in the problem. So these are our given quantities. And then the mass for the ball A is 1 kilogram, which makes things easy to do. Okay. All right. So let's go ahead and find the mass of the second ball. So because this is the collision problem, you want to set up conservation of linear momentum. So here I have the net momentum initially equals to the net momentum in the final reference frame. Here there are two objects initially. So I have PAI, PBI equals PAF plus PBF. But it says that it says ball B is initially at rest. That's just hanging until it got hit. So I'm going to go ahead and cross that particular term out. So the momentum of ball B initially does not exist because it's just not moving. So here I'm just going to go ahead and expand everything. Because it says sticks together, it'll dictate our statement on the right side of the equal sign. So here I'm just going to go ahead and break up PAI into MA, VAI, and then on the right side I'll have MA, VAF plus MB, VBF. However, because it says it sticks together, I know that VAF and VBF have to be the same because they move off with one speed. So I'm just going to go ahead and get rid of the subscript A for V and also the subscript B for BF here. So I'm just going to call it VF. In this particular problem, I won't combine or factor out VF because you're asked to find the mass of MB, which is just in this term. So it's entirely up to you, but I'm just going to keep my work the way it is. So here I'm just going to plug in variables. MA is just 1 kilogram because it's given. The speed of VA before it strikes the sphere B is given as 2. And then here, MA is just 1. VF is given as 1.2 because once again, they stick together so they move off with the same speed. MB is what I'm trying to look for, which is my unknown. And then I substitute in VF here for 1.2 as well. I'm just going to go ahead and cross out meters per second just so it looks a little cleaner. So here, 1 times 2 is just 2 kilogram, and then 1 times 1.2 is just 1.2 plus MB, and then the 1.2 remains. I'm going to combine like terms. The next algebra step I'm going to do is I want to move this 1.2 from the right side of the equal sign to the left side to combine like terms, so that'll become minus. So here I have 2 minus 1.2, which is equal to the remaining terms on the right that I haven't moved, which is MB times 1.2. But other than that, 2 minus 1.2 gives us 0.8. And then to get MB by itself, you would have to divide both sides by 1.2. That is why the 1.2 here is in the denominator. So I did 2 steps in one here. I simplified this left numerator. I simplified the left side of the equal sign. And then at the same time, I divided by 1.2. So here you have 0.8 kilogram divided by 1.2. So therefore, the mass of block B is 2/3, or if you like, it's 0.666 floating. So I just ran off to a 0.67 kilogram. And that is the answer for this particular problem. Okay? All right, stay nerdy, don't be white.